Okay, so we're going to begin the third unit, and this is one of those times where we have the rules here are actually really good. So this might be a decent reference point for you as we get into exponent rules and all the different kinds. Please remember that the exponent rules usually are on the wall, but if not, I can find extra resources like shortcut sheets, and I can have those available in Google Classroom as well. I also really recommend that you go and take the time to look up some YouTube videos for these, because there are so many of them. There's hundreds, and there's lots of different ways to learn exponent rules. I'm only going to teach you a couple of them, but please, if you're struggling or it doesn't quite make sense the way I'm doing it, look for something else. Okay, this is algebra. There's lots of different ways to do stuff, and YouTube is a great resource. So I'm going to ignore all of this, and we're going to go down and we're just going to look at some of these examples. So we're going to simplify, which means we are going to take this and write it as one thing. Right here, I have C. Okay, so there's a rule that says when I have exponents with the same base, we add the exponents. So the base is this. That's the verb. Base is the C. It's the thing that the exponent is being attached to, and therefore we know that the exponent is the 12 in this situation. It's what's doing the raising. So I have three different bases, but the base is the same, C, C, and C. So when I have the same base, my rule says I take my exponents and I add them together. So it's going to be 12 minus 4 plus 6. So what is that? C raised to the 14th. Okay, that's the rule. Over here, we have B divided by B. I want to take this and I want to write it as one thing. Well, my rule says that if I'm dividing exponents with the same base, I subtract them. 8 minus 2. Okay. And if we look at these two examples, we have multiplying is associated with addition, and dividing is associated with subtraction. Maybe that makes sense to us. But what we have here, I don't know. I want to do it gets complicated real fast. Let's come down here and let's look at M, because 8 here is a nicer example of what number 1 is going to do for my purposes of explaining the rule. So here we have m to the 7 times m to the 8. Well, we just covered that if we're multiplying with like bases, we add the exponents. So we should just really quickly know that that's going to be to the 15. But why? Why is that the case? Let's look at it. M to the 7 really means that I have m 7 times. M times m times m times m times m times m times m. 1, 2, 3, 4, 5, 6, 7. Okay, that's the first one. That's m to the 7. Now it says I'm going to multiply it by m to the 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's what these exponents mean. M to the 7 and m to the 8. And then they're being multiplied together. So if I'm going to take all of that and just shove it into 1, I'm going to count how many m's I have, and that's 15. That's why this works. Okay. But the division one, is there a nice one with division? No, not really. Okay, so let's go back up and learn why the division rule works. Here we go. What this is saying is I have 8 B's on the top. 1, 2, 3, 4, 5, 6, 7, 8, and they're all being multiplied. And I have 2 on the bottom. Okay. Well, B is just a variable. B can be anything. B could be 5, it could be 500. But I do remember from maybe way back in the day, if I have the same thing on the top as the bottom, I can cancel that. So a B on the top is going to cancel with a B on the bottom, just like that. Nothing's on the bottom anymore. So what I'm left with is 6b's on the top, so b to the 6. And that's the explanation of why that one works. Let's go over and look at number 3. So we have another rule. It says if I have a base to an exponent inside a parenthesis, and that parenthesis itself has an exponent, my shortcut says I multiply. I multiply in. So it's going to be 5 times 4. A to the 20 is my answer. But why? Why does that work? Why does that rule work? Sometimes it gets confusing about when do you add exponents and when do you multiply them. So let's figure out what this actually means. It's saying I have a to the 4 and I'm raising it to the 5th. Okay. So that means I have a to the 4 5 times. Okay. I really have that. I have this thing 5 different times. And now, if I break this down, that means I have 4 a's. And then 4 more a's. And then 4 more. See where I'm going with this. And now I count out, if I want to cram all of this into 1, 2, 3, 4, 5, 6, 7, 8, all the way, I have 20 A's. Okay. So that's a visual demonstration of why this works and why the shortcut is so important, because we would want to do this every single time. Okay. So let's keep going. I think I want to do number 5. Yeah, okay. So number 4 has negative exponents. And we have a rule that says you can't have negative exponents. Negative exponents aren't allowed. So in order to do this nicely, I'm going to keep everything in a row. We're going to team up the x's together, and I'm going to group up the y's together. Okay. And my shortcut, I'm going to ask. I need to figure out where the x's are going to be. I'm going to say, all right, what x has more x, the top or the bottom? And you would tell me, well, you compare -2 and +4. Which is more? The bottom. -4 is bigger, or sorry, +4 is bigger than -2, so my x is going to live on the bottom. How many more x's is this bigger than that? It has 6 more, right? The difference here is 6. So 6 x's live in the bottom. Okay. There's an invisible exponent in this top y, invisible 1. So which y has more y? +1 or -1? Well, +1 is bigger. And what is the difference? It's bigger by 2. So that's the answer. Y to the 2, x to the 6. But why? Okay, let's explain. So back to the x's. Here's another way to view it. You're not allowed to have negative exponents. So how I change something from negative to positive is it needs to change sides. If it's in the top, it needs to go to the bottom. So it's going to go to the bottom, and that -2 is simply going to become +2 as it moves from the top to the bottom. So that means this is going to turn to +2 by the time it hits here. And that's x to the 4 plus 2 more gives me x to the 6. In the bottom here with the y, I'm not allowed to have -1, so it needs to change sides. But as it's changing sides, it's going to change to be positive. So this 1y up here, another +1 is going to be added to that. And that's why I have a 2. Okay. That's the rule that says x to the negative, I don't know, let's make up a number, is the same thing as 1 over x to that thing becoming positive, because it needs to go to the bottom, it needs to go to the opposite side, and it needs to change. Okay. 5. Okay. I got a lot of stuff happening here in 5. I got a's and b's, and I got parentheses, and I got exponents, and some of it's negative, and it's bad. But one thing at a time. This -1 means I'm going to, well, if you raise anything to the power of 1, it doesn't change it, right? Like 3 to the 1 is just 3. So changing it to 1 does nothing. But that negative does do something. That negative will flip this whole thing on its head. So I'll take it, a to the negative 3, b to the 2, over a to the 2, b to the 1. I'm just gonna write the 1. Okay. Now, we can simplify this by keeping everything in its lane. A's with A's, B's with B's. So, looking only at the A's and looking only at the B's. I need to simplify, which means I need only one instance of A and one instance of B in my final answer. Okay, I got a fraction. Which A has more A, top or bottom? And you'd be like, positive 2 is more than negative 3. So my A lives in the bottom. How many more A's, or how many more is negative 2 than that? You'd say 5. Negative 2 is 5, or sorry, positive 2 is 5 more than negative 3. Alternatively, you could be like, okay, the negative is gonna need to go downstairs because it's gotta become positive, and then 3 is gonna be added to 2 to make 5. Okay, which B has more B's? The top. And how much more is 2 than 1? 1. Also, you could look at this one, right? This is the division rule. This one is saying, I have 2 B's in the top, 1 B in the bottom, and just like before, cancel, cancel. So I have 1 B living in the top. Lots of different ways to explain exponent rules. Number 6. Okay, number 6 has a parentheses and then an exponent on the outside. I'm gonna need to get rid of the parentheses first before I can do this. And how I'm gonna do that is this 2 is going to need to get distributed to everything, not just in the top. It also needs to go to the stuff in the bottom. So I'm gonna rewrite this. Okay, X, and then it's 2 being squared. When you bring stuff in from the outside, a parenthesis, you multiply it. So 2 times 2, make 4. And visibly there's a 1 here. So y 1 times 2 is y2. An invisible 1 with that x. So when I multiply that, and then there we go. 3 times 2 is 6. Okay. Now I need to simplify this, which means I can only have 1 x and I can only have 1 y. Which x has more x's, top or bottom? And you'd say top. How much more is 4 than 2? You would say 2. And that's it. How much y has more y? It's the bottom. And the bottom has 4 more. Okay. So that's my answer. If you wanted to blow this one up, you would say that I have 4 x's on the top and 2 y's. And I would have 2 x's down here and 6 y's. And then you would go canceling where you can. Cancel, cancel. Okay, I'm left with 2 x's in the top. Makes sense. And then cancel a y with a y. And I'm left with 4 y's in the bottom. Makes sense. All right, number 9. Okay. Just like with exponents, real numbers will stay. No, don't do that. I want to highlight, man. Okay. Real numbers will go with real numbers, and it will not affect the variables at all. Keep everything in its own category. So, 8 over 4 reduces to 2 over 1. You don't need the 1 in the bottom, but it might be nice to put it there. Okay, m's, 3 on top, 1 on the bottom. More on the top and more by 2. N's, 2 on the top, 3 on the bottom. More on the bottom. but just one more. Okay, that's my answer. And you can explode this one just like you exploded the other one if you want to. Okay, what else we got here on the front? I think I did most of them. Let's do number 7. No, let's not do number 7. Keep it moving. All right, we need to simplify. So we're gonna combine like terms, really is all we're doing. We're combining like terms here. So all of my x squareds, I'm gonna compare them. 6x squareds, 4x squareds, negative 3x's plus an x, plus 2 minus 3. Okay. So as we put this together, we see that this group is closed off by a parenthesis, so is this one. I'm taking this group and I'm subtracting this amount, okay? There's no multiplication. There's not gonna FOIL this, you're not gonna distribute, it's not gonna blow up to be this giant horrible problem. I've seen that in years past where kids do that, and they're like, okay, I gotta FOIL this and I gotta multiply, and they give me a paper that looks like this long. No, it's so much more simpler than that. We're just taking this amount away from here. So 6x squared minus 4x squared is 2x squared. Negative 3x minus a positive x. Negative 3x minus an x. It's minus 4 x's. 2 minus a negative. Minus a negative turns positive. 2 plus 3. And that is the final answer. Combine like terms. Over here in number 2, I'm adding this chunk to that chunk. So I don't even need to really worry about, I'd subtract negatives over there and stuff and think about how that affected it. No, we're just combining. So I got the y squareds here. I'm gonna highlight the y squareds. I'm gonna remember that I need to take the sign with it. I got some xy's, and then negative x squared, negative x squared. Okay, let's combine these things. 7y squared minus 3y squared, or 4, gives me 3y squared. 7 take away 4, give me 3. I have 12 xy's plus 6 more xy's. That's 18 xy's. And then finally, negative 3, negative 5 make negative 8x squareds. That is it. Okay. I'll do a couple more of these. I'm subtracting. Negative 4m squareds plus 4m squareds. Negative 6m's, positive 6m's. Okay. Don't fall into the trap and be like, okay, I've got negative 4m squared plus 4m. It's going to be 0. It's going to cancel, right? Negative 4, positive 4 gives me nothing. But that's not true because I have to pay attention to the sign. Negative 4m squared minus positive 4m squared. The negative is going to win. Negative 4m minus 4m gives me negative m, negative 8m squared. Minus 6m minus 6 more m. Okay, don't tell me that whole thing is 0. That's a trap. Let's do 6. All right, I got p cubes. Where else do I see p cubed? Right here. I got negative 15p squareds. Boom. All right. 24p3 minus 15p3 leaves me with 9 left over. P cubes. Negative 15, positive 13 minus 2p squared minus 4 p's. Okay. So this stuff is pretty easy. Damn, that's what I give you. Okay.